Now we're going to look at transformations of graphs. The first thing that we're going to look at are translation. Adding or subtracting a constant outside the function translates a graph vertically. However, adding or subtracting a constant inside the function translates the graph horizontally. But this does the opposite. Let's see what I mean. If a is positive and a is added inside the bracket, the graph is going to move a to the left. And this can be represented by this vector. Let's look at an example. Given that f of x equals to x cubed, we have to sketch the graph of y equals to brackets x plus 1. We immediately know that we're going to move the graph 1 to the left. So first we're going to draw the graph of y equals to f of x, then translate it 1 to the left. And in order to find the intersection with the y-axis, we will let x equal to 0, and 0 plus 1 is 1, and 1 cubed is still 1. Therefore, the intersection with the y-axis is 0, 1. You also need to know that when you translate a function, any asymptotes are also translated. Let's look at an example, in which given that h of x equals to 1 over x, and we have to sketch the curve with the equation y equals to h of x plus 1. From the equation, we get that this is going to move 1 up. Therefore, we would first sketch the curve of y equals to h of x and move it 1 upwards. The next thing that we're going to look at are stretching graphs. You need to know that the graph of y equals to af of x is a stretch of the graph y equals to f of x by a scale factor of a in the vertical direction. Just think of it like this. If the value of x remains the same and the function is multiplied by more times, then you will get a bigger value of y if y is positive and a smaller value of y if y is negative. Therefore, we will see a stretch of the curve in the vertical direction. However, the graph of y equals to f of ax is a stretch of the graph y equals to f of x by a scale factor of 1 over a in horizontal direction. And let's visualize this on a graph. You can observe that the bigger value of a, the more squeezed up the graph is going to occur. The next thing that you need to know is the graph of y equals to negative f of x is a reflection of the graph y equals to f of x in the x-axis. You can actually try to understand this instead of memorizing it. Just think of it like this. If x is positive and the function is multiplied by a negative number, then y is negative. But before this function, y was not negative. So y is translated in the horizontal axis. And similarly, the graph of y equals to f of negative x is a reflection of the graph y equals to f of x in the y-axis. And this is because before x was positive and now x is negative, so it is translated in the y-axis.